If the sun were suddenly replaced by another object in the sky, such as a black hole, a neutron star, or even the moon, what would happen? Could we continue living on Earth, or would we be doomed? This is an intriguing question that challenges both common sense and our understanding of the mechanisms that sustain life and stability on our planet. So, let's explore these hypothetical scenarios and the consequences of each one, comparing them with real data and phenomena. The idea of a black hole replacing the sun might seem like the immediate end of everything. But surprisingly, it wouldn't be as catastrophic as it appears, at least not in gravitational terms. If the black hole had the same mass as the sun, the gravitational effect on Earth and the other planets would be almost the same. They would continue orbiting the black hole in much the same way they orbit the sun. This is because the gravity of a black hole at a distance functions just like the gravity of any other object of equal mass. But that's where the good news ends. The first and most obvious difference is that a black hole does not emit light. This means that Earth, along with all the other planets, would be plunged into total darkness. The sunlight that warms and illuminates us is essential for life on Earth, not just for regulating temperatures but also for enabling processes like photosynthesis. Without light, photosynthesis would come to a halt immediately. Within a few weeks, temperatures on the planet's surface would plummet to deadly levels, perhaps around -100 degrees Fahrenheit or -73 degrees Celsius, a drop that surpasses even the extreme cold of Antarctica. There wouldn't be enough heat to sustain life as we know it, and Earth would become a frozen globe. In the depths of the oceans, extremophiles, organisms that thrive in conditions considered hostile to most life on the planet, could survive for a while because they rely on Earth's internal heat, not solar energy. However, even they would face an inevitable fate as Earth's geothermal heat gradually escaped into space. Eventually, all life would cease. If, instead of a black hole, we had a neutron star replacing the sun, the outcome would be quite different. Neutron stars are remnants of massive stars that exploded as supernovae. A typical neutron star might have about 1.4 to 2 times the mass of the sun, but it's compacted into a radius of just 6 to 12 miles. For comparison, it would be like taking the mass of the sun and shrinking it down to the size of a small city. If a neutron star with a similar mass to the sun were placed at the center of the solar system, Earth would continue orbiting as before, in gravitational terms. But the reality would be far more brutal. Neutron stars spin rapidly and emit powerful beams of radiation in the form of radio pulses, X-rays, and even gamma rays. These beams are so intense that if Earth were hit, the entire surface of the planet would be quickly sterilized. The harmful radiation would destroy the ozone layer that protects us from ultraviolet rays, leaving Earth exposed to lethal levels of radioactivity. Moreover, neutron stars do not emit enough visible light to warm or illuminate the planet. So, just like in the black hole scenario, Earth would quickly fall into an eternal and frigid night. Once again, life would freeze, and the surface of the Earth would become uninhabitable. The moon in place of the sun, it sounds absurd, but it's an interesting hypothetical scenario to analyze. The moon is approximately 400 times smaller than the sun and, of course, doesn't come close to having the mass or the ability to emit light and heat. Practically speaking, if the moon were in the sun's position, the first immediate effect would be the total loss of natural light in the solar system. After all, the light we see from the moon is merely a reflection of the sun. Without the presence of sunlight, Earth would immediately lose its stable orbit. That's because the sun's gravity keeps the planets in their orbits, and without this massive force, our planet would drift through space in a straight line, away from its parent star, heading into the unknown. This kind of event, where Earth becomes a planet without a translational orbit, would bring even more disastrous consequences. Without the sun's stability, Earth would be thrown into an unpredictable space environment, where temperatures would plummet. The heat remaining in Earth's core would take some time to dissipate, but not enough to prevent life from freezing to death within a matter of weeks. If the sun were to simply disappear, Earth would experience a brutal impact. Within a few days, global temperatures would begin to drop, and in a matter of weeks, the planet's surface would become too cold to support life. The oceans would freeze from the top down, forming a crust of ice that would only grow thicker over time. Mercury, the closest planet to the Sun, would undergo a dramatic transformation. Currently, Mercury is known for its extreme temperatures, which can reach up to 805 degrees Fahrenheit or 430 degrees Celsius during the day, while at night, without an atmosphere to retain heat, they plummet to -290 degrees Fahrenheit or -180 degrees Celsius. With the Sun's absence, Mercury would rapidly freeze over completely, reaching temperatures far below those recorded at night, as there would no longer be an external heat source. The surface of Mercury would become a vast, frozen, and barren wasteland, locked in ice forever. Venus, famous for being the hottest planet in the solar system, with surface temperatures reaching almost 870 degrees Fahrenheit or 465 degrees Celsius due to its runaway greenhouse effect, would also face a freezing fate. Without the sun's heat, the thick mantle of carbon dioxide covering Venus would stop trapping heat, and the planet would transition from a toxic furnace to a colossal block of ice. This wouldn't happen immediately, as the trapped heat in Venus's atmosphere would keep the planet warm for a while. However, within weeks or months, global cooling would set in, and Venus would plunge into extremely low temperatures, becoming a completely frozen and hostile environment. Beyond all these hypothetical scenarios, it's worth considering what will actually happen to the Sun in the future. Our Sun still has many years ahead, about 10 billion years in total, before it begins its transformation into a red giant. When that day arrives, the Sun will expand, possibly engulfing Mercury, Venus, and maybe even Earth. By that point, Earth's surface will likely be completely scorched. Eventually, the Sun will shed its outer layers and become a white dwarf, forming a hot and dense core but without the same capacity to provide light and heat as it does today. For a time, this white dwarf will still emit some light, but it will slowly fade over trillions of years until it becomes a black dwarf, a dark and cold body. As with the previous scenarios, life on Earth, or any remnants of life that could survive such an event, would need to find a new home in another star system. If this glimpse into the Sun's future has left you intrigued, subscribe to the channel and join us as we explore stars, planets, and the mysteries of the universe. See you soon in the next video.